We're going to explore chemical mixture problems type B. Type B. So how you solve for these is going to be just slightly different than type A, but you will have to learn to recognize the difference between type A and type B problems. So let's look at this example, and I'll just show you how to do these and teach you some clue words. It says how much water must be evaporated from 100 gallons of a 10% brine solution, brine just means salt, to get a 40% brine solution. Okay, so there's two different formulas that we can use here. Well, let me show you the two different constituents. We have water, all right, and we have brine, and I'm going to call it salt, because that's going to make more sense. We have water and salt. So if we have two different constituents, then therefore we could actually use two different solutions. And I'll show you them. Salt 1, and that's our initial amount of salt, and I'll go over that in a second, minus your salt out, whatever was subtracted, equals your salt final. And then I just did subscripted variables there. Or you could say water 1, your initial amount of water, gallons, percent, whatever it is, minus your water out, and the word they actually use there is evaporated, so we'll go back to that in a second, equals your water final. And then you see the subscripted variables. So let's look at this. So we know that we have water and salt. So I just showed you those two formulas. Now let's look at our clue words. One clue word is going to be evaporated. When something is evaporated, it means you have less, right? You get water, you know the science. You have less water. And so, therefore, let's see if we can get this in the middle of both. Yeah, you should be able to see that. So when we look at, it says how much water must be evaporated. So on this side, this blank would be our evaporated blank, or variable in a sense, because it talks about how much water must be evaporated. However, over here, we said salt out. Well, this didn't say how much salt must be taken out, it said how much water. So therefore, we don't know how much salt would be taken out. So know the difference. If it says how much must be evaporated, that has to be plugged into the water rather than the salt in this problem. So that's a clue word there. Then it says from 100 gallons of a 10% brine solution. So it's saying how much must be evaporated from 100 gallons. So what that means is 100 gallons is our initial, dang it, you can't see that. 100 is our initial amount or measurement. All right. So what we can do is plug in the 100 here and plug in the 100 here. So I'm going to go ahead and do that. 100 minus, now let's look at how to use the 10% brine solution. If it says 10% brine, okay, this 10% of is generally a keyword for multiplication. All right, remember of equals multiply for the most part. Not every time it says it, but so we can go ahead and say 0.1 of 100. So how much of water must be evaporated from 100 gallons of a 10% brine solution to get, okay, to get is the key word, because to get would mean equals. All right, so what it's about to tell us is what is equal, or what it equals on the other side. It's going to tell us our final. To get a 40% brine solution. Now notice it only gives us 40%. So I'm going to write 40% over here. So now we've plugged in our numbers that we initially know. Here's how you do the other part. This can be confusing, but what we're basically going to do is substitution. If I look at this right here, okay, let's isolate this. We know that salt final equals salt 1 minus salt out. Now what we just did was plug in 100 for salt 1. So if I'm looking at this in our subscripted variables, it looks like this. But we know that salt final equals 100 gallons minus however many gallons of salt are poured out. And so what I can do is plug in 100 minus, I'll call it salt out. So then we're close. Now we've plugged in our variables. Now from here, here's where it kind of gets interesting. We actually know that no salt is evaporated because it says how much water must be evaporated. Here's where you kind of got to pay attention. Water must be evaporated. So therefore, zero amount of salt is evaporated. No salt is evaporated. So what I can do here is plug in to this salt that is poured out. I can multiply it by 0. Multiply it by 0. I'm going to rewrite this to where you can see it a little bit better. And now from here we can solve. So 0.1 or 10% of 100 is 10 minus 0. Okay. 10, so therefore 10 equals 40% of 100 is 40. We still do distribute here. So, sorry, minus 0.4 salt out. And then we solve minus 40, minus 40. Negative 30 equals negative 0.4 salt out. So the amount of salt that was evaporated when you divide is 75. 75 gallons evaporated. And that's our answer. So that's how you do it with the salt way. Now I want to I do want to show you the water way, because probably many of y'all might be able to see the water example a little bit better. And so I'm going to use this also. Once again, I'm actually solving for the same problem. We're going to get the same answer. I already know my amount evaporated is 75, but I do want to show you this way, and I'll do it a lot quicker because I know the other one kind of is time consuming. What we already knew was 100 gallons is our initial amount. All right, that's our start. So that is our water 1. We also knew we had 0.1% of brine, and I'll call it 1 because it was in the 1. It was multiplied by the initial amount. So if we have 0% or 0.1% of brine, then that means we have 0.9% of, or well, I guess it's not percent. 90% would be what we have. Water. So notice that it's adding up to be a total of 100%. So I can write 0.9 for 90%. Minus water out. Well, we do know that some is evaporated, but we don't know how much. We can use the subscripted letters WO, or we can make it easy and just use an E for evaporated. But remember, water was evaporated. Salt wasn't evaporated. I don't think that's possible. Not a science teacher, but pretty sure that's true. Then it said to get a 40% brine solution. So 0.4 was the brine final, so therefore 0.6 is water. Hopefully you're understanding this. So 0.6, and just like we did before, we're going to substitute what we have here. Substitute this 100 minus WO for WF. That's where we substituted, and then we solved, or then we would solve 90 minus E equals 60 minus 0.6 E, and so on and so forth, plus E minus 60. 0.4 E equals 30, and when you divide, you would get 75 again. Okay, 75 gallons. So hopefully you got the idea there. Now we're going to look at one more. I'm going to do this one a little bit faster, but it's the same thing. It's just an addition one. It says in example 61.2, it says, when Frank and Mark finished milking, they found that they had 900 pounds of milk that was 200 or 2% butterfat. How much butterfat did they have to add to raise the butterfat content to 8%? So I went ahead and highlighted your keyword here, add. The past one said evaporated. This one's talking about adding. Now our variable is a very gross word, butterfat. So I'm going to say butterfat 1. I'm just going to say B. Butterfat 1 plus the amount added of butterfat equals your final amount. Alright, now we plug in what we know. We know that they had 900 pounds, that was 2%. That was their initial amount. Alright, 900 pounds, 2%. That's your B1. 900 times 0.02 plus, it wants to know how much did they have to add, so we don't know how much it was added to raise the content to 8%. To raise, so to get 8%, 0.08. And just like we did on the last one, we know our butterfat one is 900. That's our starting amount. So now we're substituting this in for butterfat. So 900 plus the amount added, and then we solve. 2% of 900 is 18. We distribute here. 8% of 900 is 72. And then we distribute there. Solve for like terms. I'm going to subtract 18 here. I'm going to skip through some of this math pretty quick. I'm going to subtract that here. So when we do, remember if there's just BA there, that's the same as saying 1. So 1 minus 0.08 is 0.92. And then 72 minus 18 is 54. Divide by 0.92 to get BA by itself. 54 divided by 0.92 is roughly 58.7 pounds. So the added amount is roughly 58.7. That's how you do chemical type B problems. It just takes some practice, and we'll practice knowing the difference between type B and type A. But clue words are things like add, evaporate. Those are the main ones that you're going to see.